My name's Gavin Clark, and I'm with the museum. And we're here on Zoom and in the museum itself to celebrate this special day. And with us, we have three of the principal characters who are behind the making of that computer so long ago. Is that a bad thing to say? We have Hermann Hauser, who was the co-founder of Acorn Computers. We have Sophie Wilson, of course, who is co-designer of the BBC Micro's operating system and ARM processor, and who wrote the BBC Basic Programming Language. And we have Steve Furber, a principal designer of the BBC Micro and the ARM processor. Some context and hindsight. The BBC Micro dramatically excelled expectations. I think the goal was for 12,000 units sold, and it hit 1.5 million. Present in more than 80% of schools in the UK. It landed in the UK at a very fortuitous time as personal computing started to leave the hobbyists and move into what we might call the commercial mainstream. But enough of that. Let's go back in time. It's November the 30th, 1981. It's the eve of the BBC Micro's official launch in the UK, at least. I've got Hermann, Sophie, and Steve. They're out sweating about the imminent launch of this event they've been involved in. What was the feeling like inside Acorn headquarters about this night 40 years ago? Give us your thoughts. Go take your minds back for us.
Well, it was very exciting because for a little Cambridge company to be thrust in front of the nation all of a sudden through the BBC, which at the time and still is one of the main voices in the UK, was very exciting, and I think we're looking forward to it with trepidation, but also with excitement.
Steve and Sophie, you'd obviously put a lot of technical work into it too. What was your theme? What was your sense on this night, November the 30th, 1981? Were you cool and collected, or were you a bit frantic?
I don't remember it at all, but I can imagine that I was sitting there wondering when we get caught out by the linear power supply that the BBC insisted on, which was obviously going to catch fire at some point. The 81LS95 chips that drove the memory, which we never quite worked out why they worked, because none of the substitutes which had identical specs ever worked at all. How were we going to stop the ULAs from overheating and causing the display to break up? I think those were probably the main thoughts going through my hardware guy's mind at the time.
So you being a classic engineer and you were wondering about all the negatives.
That's right.
And Sophie?
I don't think anything happened to us on that day. Our big trials were going down to assist the BBC with the first makings of the computer program, which was pretty dreadful because they had some early machines, and under studio lights, the dreaded ULA overheating events did occur, and Steve was dashing about with a can of freezer spray.
When was that, Sophie? Do you remember which month did we do that in?
I think it was something like October. So it was before the program was recorded before transmission because Micro Live was later on, but it was still relatively close to the end of the year. So
yeah, I remember I was soldering RGB wires onto the nation's live television feed at one point.
That's a remarkable. Obviously, you put a lot of work into it by this point. The launch of today, when we have major computer and software launch events and cloud launch events, there can be a lot of publicity and media attention focused on that. Obviously, you had the kind of in with the BBC. What was the kind of, I suppose, almost like theatre? What were the first reviews like? Did the review press get hold of them, these machines? What were you waiting to read those? What was the initial feedback on this device you worked so hard to deliver? What was the reception, at least the initial reception?
That was almost completely lacking. We would be waiting quite some time before things like Personal Computer World came out with a review of the machine, or any of the Acorn Focus magazines came out with reviews. In the early days of the machine, there were very few actual machines about. So throughout the summer, most of the software development was done on Acorn system machines. So very few people actually had access to real machines. I think the BBC themselves, in making the program that I talked about, very few of their machines actually worked because there were system range computers under their desks running some of the displays. I think there was a BBC micro shell with a large ribbon cable going up through it so that its keyboard worked.
And I mean, that's incredible to kind of get that kind of peek behind the scenes. Was it just the luck of the draw, these particular systems, or because they were early systems? Obviously, in the mass market, these issues, did they really come up, or was it an exceptional set of circumstances?
In the early days of production of the BBC Micro, every issue you can imagine came up.
But the main problem, as Sophie mentioned, was really the ULA. And the story was that we really pushed, and you might fill in some of the details. We really pushed these ULAs and used more of the gates than they had ever imagined could be used from the front ULAs. And we got, I think, 8 of them back, and most of them worked. And with hindsight, it turned out that this was an exceptional and unusual lot. That when the production started, I think we got a yield of 5% or 3%. So we had, because they were just not, they were all overheating or not working at all. So we had a real crisis, a ULA crisis on for quite a while.
And this got quite, because you were very much in the public eye as well as a company, weren't you? Because of the BBC, and naturally, was there, I've been saying MPs, there are questions in the House of Commons. This got a lot of national attention, didn't it?
That's right. Yes, we did have questions in the House of Commons about why the BBC micros haven't arrived in schools yet. So it was of national. It hit the national headlines.
It was tremendously difficult because it was a hard machine to build. So we'd gone with our traditional computer manufacturers, and Timex in Scotland and ACE in Wales were both not very good at building it. It took ICL to actually build it right in the early days and get it to work. So that was another pattern, quite apart from the ULAs, which I think Steve spent, post-launch of the machine, Steve and I both vanished down rat holes trying to fix stuff. I was working on the next version of BBC Basic, and Steve was working on the next version of the ULAs to try and get them to meet specs. Steve had read the data sheets carefully, and he was within spec on the data sheets, but the Ferranti ULAs didn't meet the data sheets, especially at temperature.
At what point, I suppose, in the life cycle of the BBC Micro do you think all these issues were ironed out? You could reliably, or you put a system out in the market, you think, yeah, we solved all those problems? Or was it always a case of, my God, if this happens again, that's gonna pop up?
Well, manufacturing control was a major problem for about the first calendar year, and then it did get hammered down. But
the first breakthrough was when the BBC relented on insisting on a linear power supply and accepted that the case was not big enough to keep a linear supply cool enough. And so we moved to a switch mode supply from Aztec. And after that point, all the problems with the power supply went away.
I think
yes, it's sort of surprising to remember that switch mode power supplies were a revolution really in power supplies, but because they were a new technology, the BBC was reluctant to embrace it, although it was clearly running a lot cooler than the linear power supply. It was very efficient, but it was, as the name suggests, it had that these high switching voltages, and it was black magic to some people.
The BBC gave you a very exacting specification, didn't they, in terms of what they expected you to build there? You mentioned there the the linear power supply. And there were other aspects. I'm trying to pull them out. They wanted an unsurpassed range of outputs, input output for programs, a cassette interface, a printer connection, a printer connection today seems horribly pedestrian. The ability to mix graphics and surprise, text on a color screen. I mean, God, this is the sky is falling here. What from a hardware perspective, and I'll come to you in a second, Sophie, to talk about BASIC. Well, maybe you can contribute this too. What did, let's assume the BBC didn't quite get everything it wanted in the final machine. There was a spec sheet and you gave them something at the end. What did you manage to talk them down from, and on what kind of basis?
Well, I mean, the BBC started wanting a Z80 running CPM, and we offered them neither a Z80 nor CPM, except through the Proton's potential second processor interface. So they got a 6502 running a proprietary operating system. But the hardware really, I mean, the core hardware was Acorn's own design, and the principles of operation of the memory and the video and the processing and so on were all locally developed. What the BBC sort of added was a lot of interfaces, like you described, most of which were pretty straightforward. So, the 1 megahertz bus was not technically challenging. It was just more stuff, and keeping the amount of stuff down to the level where it would fit in the case that was proposed was a challenge, and we addressed that by mopping up quite a lot of chips into the ULAs, which then caused their own problems later. Although the serial ULA, I don't think, caused any problems at all. But for example, the BBC wanted not only the regular display modes, which, as you say, mix graphics and text, but also a teletext mode. And the entertainment there for me was that the machine was running off a 16 megahertz clock, and the teletext chip required 6 megahertz. And we didn't do clever things like phase lock loops in those days. So I generated 6 megahertz by some interesting, slightly analog digital circuitry. Also driving, the idea was that the BBC Micro would plug into a standard TV, so we had to send RF out and interfacing to the RF modulator, which was a little off-the-shelf metal tin box, impose some constraints because you have to generate the appropriate color carrier signal to generate the color picture on the TV. So there were quite a lot of fiddly bits.
What would you say there? You mentioned they wanted a ZX running CPM. In their mind, did they want a computer? They wanted a cheap computer that was capable of doing every single thing, or they wanted a very rich specification at a low price? Well, how would you kind of categorize what it was they were after?
I think they were just after a standard, and that was the only, that was the major standard in the industry at the time, is my feeling.
Yeah, so I don't think, I mean, the ultimate BBC spec was definitely the result of a negotiation. I mean, the BBC didn't dictate what they would have, but they had some ideas of what they wanted, and the final spec was resolved through negotiation and was a compromise. I think there was quite a lot of constructive tension between the two sides when it came to resolving the spec.
How I suppose technology literate were they? How kind of committed were they to what they wanted?
Well, my feeling was that the original list had everything in the kitchen sink in it, because it was, I think it was John Cole, wasn't it, who was one of their advisors to advise them what the schools would like to have. So John just made a list of all the things that he could think of, and made it into the spec sheet. And as Stephen said, we then negotiated them down into something that looked more like Steve's original Proton.
And of course, a big part of the tension was they wanted everything, including the kitchen sink, at a low price, and that was clearly not a consistent set of requirements. So there had to be compromise, and there was a bit of compromise over the price, which went up fairly early on, and a bit of compromise over the spec.
Having said that, most of the, first of all, the spec was, more extensive than any of the competitors that we had. And we gave them more of the spec than any of the other 6 competitors for the BBC Micro program. But we actually gave most of it to them in the end. So we were very accommodating whenever we. One was the mode 8, the teletext mode, which really was quite a technical feat at the time, because I don't think there was another computer at the time, or at least for some time to come, even after that achieved that feat.
And Sophie, just bring you in here, the same went for the programming language. They wanted something, if you could sum it up, they wanted something that was powerful, accessible and structured, that would encourage good practice. What kind of, did you have to talk them down from features, or was it more kind of, you had more of a kind of, I suppose, a canvas to interpret what you wanted and read that into the language?
So Acorn's basic interpreter was already significantly more advanced than most basic interpreters, with more structured programming features. So in fact, we had to take things out. So at the time, the interpreter had things like go to label instead of go to line number. I didn't like line numbers, so I'd been stripping them out. So the interpreter was much more like what BBC Basic eventually became, particularly the ARM version of BBC Basic, than it was like the BBC Basic that was launched with version 1. There were a lot of other minor differences. There were some stages where I won. I didn't have to adopt all the print using stuff, which would have been a tremendous amount of work, so it was just as well. I had to put in on go to and on go sub, which I also didn't like doing. Operating system wise, the specification of the operating system, they didn't really know what operating systems did or what Acorn's operating system could do. They had very little idea of a graphics system controlled and run by the operating system. So all the stuff that we made the operating system do in terms of graphics, drawing graphics, and later on the graphics extension ROM, which could do ellipses and all sorts of things, that was all us. They had never seen computers that could do that. And Steve mentioned the added bits of hardware. He didn't mention the digital PAL encoder, which was, I think that was people from Kingswood Warren and Steve working together to come up with a digital PAL encoder that was cheap and reliable. We smuggled in some things, so the second processor connection, they obviously weren't thinking of a machine as flexible as the BBC Micro, the Proton design that we'd come up with to break the log jam within Acorn. Proton was professional Atom, the next version of the Atom done right, as it were. And everybody in Acorn had their own idea about what that would be. So Andy Hopper wanted a scientific orientated workstation. Hermann wanted a business machine. Most of us wanted the computer that was our own favorite. And that was a big logjam within Acorn for quite a long time, which was finally broken by declaring that we'd make a multiprocessor machine. So the BBC computer is just the I/O processor of the original machine. And when you add language processors to it, it becomes all of the things that people wanted.
Coming back to BBC Basic, we did actually have a design committee for BBC Basic, which I chaired for my sins, with, of course, Sophie on it. And who was the person at the BBC who had clear ideas of what a basic interpreter should look like?
So Richard Russell at the BBC was in charge
That's
from
right.
their end, and John Cole and somebody else was on it. Was it David Johnson Davis, or was that too early? Anyway, yes.
I do remember they got a bit heated at times because Richard and Sophie in particular disagreed on some of the finer details of syntax for BBC Basic, but I remember we managed to win most of them.
We did.
I'm intrigued by this idea of how technical they were, and they had experts. But did they look to you as the technology guys, or did they have much technical? To what degree would you say they had technical understanding of what computers were? Because they had the bigger idea in mind, didn't they, of the computer literacy project?
I suppose they had all the ideas in mind from somebody who wouldn't have to build it.
Yes, that's exactly right. They came from a user point of view. They had two main inputs. One was the input from the BBC itself, who wanted basically, because let's not forget the whole reason for having the BBC literacy project was to educate the nation about processes. So it really had to cover everything, to cover the whole waterfront. So that was one way we were pushed by the BBC. And then there was also the BBC Micro in schools. So they had input from the teachers who had their own, mainly through John Cole, who had their own ideas what a BBC Micro should look like in schools. And then, of course, what they really wanted was to combine all these requirements in one machine and do it cheaply, as Sophie said.
Let's talk about I suppose your motivations as a company and individuals. The BBC came at it with this sense of idealism, clearly, with the computer literacy project. What Acorn was clearly looking for its next, had been, as you mentioned, discussing what the next follow-on computer would be to what you already had in the market. As a company, did you approach this from an idealistic perspective? Wow, we can inform that we can help the children, we can raise programming literacy in the country, or was it more of a kind of business decision? Was it cold hard business for you guys, or was it attempt to get one over the competition, the Clive Sinclairs out there, or was there a kind of did you have a motivation, or could you characterize it in some sort of way?
Yes, to win that competition, because it was clear that the BBC, had fantastic marketing capability, and they were looking for a computer for their program. And we were one of six companies that bid for it. So we bent over backwards to try and get that contract, and we finally managed to convince them with a prototype that we put together in 4 days or something. That we knew what we were doing. And I think that didn't fail to impress them, because they had been working with a company called Newbury Laboratories for 2 years, and they still didn't have a working computer, and they came to see us with their fancy spec on a Monday, and they had a prototype of the computer when they returned on Friday. And I think that was helpful.
Well, I want to come on and talk about that in a second, but what about Sophie and Steve? Did you have a sense of idealism, or was it just the business, the competitive aspect for you guys?
Oh, I don't think we were business people at all, really.
Still aren't.
I think our major motivation was to build machines that we would like to use ourselves.
And I think that was really the reason for the great success. The specification and the design of it was done by the people who actually finally wanted to use it. So that's why there was such a, you can't have a better market research to specification loop than we had, because the people who designed the computer actually designed it for themselves.
Let's go back to this infamous Sunday evening, shall we? This phone call that Hermann made. Obviously, the bit was between his teeth, and he wanted to convince these two non-business technology types that this was their best interest, and they couldn't resist the technology challenge, didn't he? So, how did it go down? What happened? Come on, spill the beans.
It's become a bit of an apocryphal story. I think it was.
I think actually that's one of the things which Micro Men gets quite close to the actual historical fact. You played us off against each other, and you know you did.
Yes. So I phoned, I think, Sophie first, and said, Sophie, could we get this done by Friday? And Sophie said, absolutely no way. So I then phoned Stephen and said, Stephen, is there any chance of getting it done by Friday? And Stephen said, absolutely no way. And I said, I've just talked to Sophie, you know, and he said that if we really try hard, we might just be able to do it. And he then said, well, if Sophie thinks it can be done, I'm in. And then we spent the next 3 days and 2 nights, I think. We also worked through the nights. We then got somebody called Ram Banerjee, who was the fastest gun in the West, the gun meaning the wire wrapping gun. And he wire wrapped, I think, was it 3,000 connections? I mean, some unbelievable number. And he could not only do it fast, but he also didn't make mistakes. And it was so easy to make mistakes in wire wrapping. So we actually got this wrapped in a day. And then, it almost worked on Friday morning.
Just tell us, what is wire wrapping for those of us who aren't electronics people?
Ah, right. This was a common way of not only sort of prototyping electronic systems back then, but actually some production stuff was built this way, particularly backplanes. Basically, you had a circuit board with sockets where the pins were quite long, so they'd stick out about an inch at the back of the circuit board, and they were square pins with fairly sharp edges. And wire wrap was insulated cable, which you could put in a wire wrap gun, and I think you maybe had to strip it by hand. I don't remember this, but basically the wire wrap gun would wrap the inner metal part of the cable very tightly around the pin, which you could then take around the board and then wrap it around a pin at a destination. And so you could basically assemble the complete system by wire wrapping every individual connection one at a time. And there were tricks to doing it. So if you were doing a long chain of connections, sort of A to B to C to D to E, what you learned fairly rapidly was not to do it in that order, but to do A to B and C to D, and then later do B to C and D to E, because then if you had to undo it and redo it, you only had to undo a little bit rather than the whole chain. But you ended up with these pins with 2, 3, 4 wire wrap connections along this 1 inch length at the back, to make all the connections around the board.
So if I was to ask you a blunt question, how crude was the prototype that the BBC looked at on that Friday morning, would you say? How far removed was it from that beautiful, sleek machine that we saw delivered 40 years ago tomorrow?
Well, firstly, it wasn't in a box. In that magic week, on the one side, Alan Boothroyd built a prototype of the case. So he built a model of the case, and we built a prototype of the electronics. Now, the circuit board itself was a standard circuit board. All the wire wrap was on the bottom, so basically invisible if you look from the top. But it was just a regular PC, a sort of standard PCB with chips plugged in sockets on the top. So it was fairly tidy in terms of electronics, but it was not in the case at all. The case was shown to the BBC separately. So, there was, this is how it'll work, and that is what it'll look like next to each other.
So it was kind of a very much a, here's the case and there's the guts of it over there.
It wasn't even the real guts, because large proportions of the machine were missing. So there was a 6502 and a 6845, and the memory system, all of that was there and running. But there wasn't a VidProc, there wasn't a video ULA at all, and no serial ULA either. And it was basically programmable into a few capabilities. I think it could do modes 0, 1, 2, but not 3.
Did show some graphics.
We did show some graphics. By the time
We
they
showed some graphics because that was one of the important things that we convinced them distinguished us from other designers, that we could do really quite fancy, at that time, high resolution graphics. I think high resolution was 640 by
640 by
480.
256 on a TV type display.
Yes.
So yes, Mode 0 graphics was there in that prototype and was running before they left the building on that Friday morning.
Guys, I'm sorry I have to leave now, but I'm late for my next Zoom meeting, but it was a great pleasure to be part of it. And, I hope you're having a great day.
It's all right, Herman. We won't talk about you at all once you've gone.
Not at all.
Bye-bye.
Thank you, Herman. Thanks for joining us.
Thank you.
What would you say then? It's one thing to buy off plan in property, isn't it? To see a model house or a model flat, and you get a very good idea for it. Do you think what you showed the BBC that morning gave them a very good idea, or were they just terribly excited because what they'd seen so far was maybe a little underwhelming from the other companies?
What they saw was a Proton prototype, so it wasn't a BBC Micro prototype. And the BBC Micro was substantially more complicated. So by the time they'd got round adding the teletext SAA 5050 character generator and all the power encoders and stuff like that, the video side of the machine was so complicated that Steve needed to make the video ULA. Their requirements for a cassette interface were similarly quite leading edge. So we had quite a lot of exposure to what you could do with cassette tapes, and we needed a more complicated version of what we got, and that also ended up in a ULM. And then there were all the other add-ons, the speech synthesis system, the provision for a floppy disk drive, the buses and so on. So the machine really did get a lot more complicated. I think the prototype was only about 30 or 40 chips. And if we'd built everything without the ULAs, we'd have been over 100 chips for a fully provisioned machine.
In fact, the BBC Micro printed circuit board takes 102 chips as it is.
Yeah.
And the VidProc probably replaces about 20 and the SurProc about another dozen.
Okay.
So at least twice what we showed them.
So it was a kind of a case of selling with the potential, I think. And did you have a hard discussion about, a very creative discussion about what the potential is, do you think?
Well, no, we showed them a Proton prototype and described it like that.
Yes, and it worked. I mean, that was the thing. At the beginning of the week, on the Monday, we didn't even have a circuit diagram.
Yes, we came in on Monday, discovered Herman's slight amount of subterfuge, and started actually converting the machine that was in our heads into a circuit diagram.
What was the feeling on that Monday morning? Did you even think about how the mountain you had to climb, or were you already kind of like breaking it down like engineers?
Who knows? It's tricky.
I don't know. I think we just thought the whole escapade was rather foolish and doomed to failure, but we do our best and just got on with it.
I mean, it was very significant in designing the memory system for the Proton. We'd upped the memory speeds of what we were used to doing. So all the system range of computers basically ran at 1 megahertz. And we'd used memory components. We had DRAM boards and SRAM boards for the system range. But they ran quite slowly, really, to meet the 1 megahertz bus. And in the BBC Micro, in the Proton prototype, we decided we'd go at 4 megahertz because I think one of us had read the Hitachi data book and they said they would have memory chips that were that fast. So we thought, oh, okay, we can use them then. So that was one of the things that made us doubt that we could make one of these Proton prototypes on Hermann's schedule, because we'd read about the chips in the data book. Did they exist? I think Chris Turner marshaled a lot of resources to get chips. We needed a 2 megahertz 6502 instead of the 1 megahertz ones that we used. We needed those special DRAM chips. So Chris was out trying to find all the bits that we'd need.
Yeah, getting the memory, I think, was a particular challenge. I think we may have got our hands on the first 4 megahertz capable DRAMs in the country. But I mean, today, if you're building a system like this, you have stacks of software tools that basically allow you to simulate everything from the sort of the thermal issues inside the case itself to the complicated features of the printed circuit boards and so on. Whereas back 40 years ago, you built it and then you debugged it to make it work. And debugging was usually a combination of oscilloscopes, and TTL logic probes were quite common devices, if people remember those, where you basically had a pen-like device that you put on a base on the circuit, and a red LED lit up if it was high and a green LED if it was low, and they flashed a bit if it was doing something different. I don't remember the precise semantics of the LED outputs, but debugging was fairly scary. And it wasn't actually with the prototype, but when we got the first PCBs out, there was a feature of the PCB was that it didn't work reliably until I discovered if I put my finger on a certain place on the back of the board, it suddenly started working. And I didn't have enough fingers to provide one for each of even 12,000 BBC micros. And so we ended up with a little resistor pack on the data bus, which was the replacement in production for Steve Furber's finger. And we never quite knew why that was necessary, but it seemed to work.
It's an interesting step back. And is it true you got hold of the only samples of the DRAM in Europe from Hitachi at that time, and that came in by personal, by executive contact or by courier or something?
I think the DRAMs, the representative of Hitachi in Europe came to England hand carrying them through customs to have them with us on the Wednesday afternoon. It was that bad.
It was real nail-bitey stuff.
Yes. Well, there were lots of reasons why we thought you couldn't have such a machine by Friday. And we were right.
A question here on a connected point here, actually, from Ed, is wondering how the PCB was designed and how much time it took without modern EDA tools, which obviously wouldn't have existed.
So Acorn employed a PCB designer. The BBC Micro circuit board I think is a straightforward double-sided board. So it's very simple by today's standards. What was our PCB man called? I know he knew his name perfectly well, but Sophie will remember, although Sophie's looking blank too.
I won't remember that because I don't think I was locked in a cupboard doing the operating system in BBC Basic.
But anyway, it was designed by hand and physically drawn, as it were, to produce the masks. And so the guy that did this, whose name I should remember, but I'm getting old, was very competent at this, and he worked from the circuit diagram. So you give him the circuit diagram and he would go and lay out the circuit board. And as far as I recall, it was pretty much entirely a manual process. And yes, there were no EDA tools of the sort that you couldn't survive without today. Even the ULA design was pretty manual. The computer lab had developed some tools that helped with the ULA verification and simulation, and they played a significant role in developing the two ULAs.
Peter Robinson.
But I think at Ferranti, when the design file got there was a layer of sticky plastic and a computer-controlled cutter that cut through this plastic and then human beings peeled off the bits that you didn't want, where it had been cut. And one frequent source of problems with ULAs was they failed to peel off a bit that needed to be peeled off. So even that was not the kind of fully automated, computer verified process that we see today.
Well, it wasn't the first time, I think, you did took this kind of process and what we might call pre-modern design times, because all skipping forward a few years and coming to RISC and ARM, you went through a kind of a similar huge intellectual exercise once again, didn't you? What was, just refresh our memories. We know the BBC Micro's first generation processor was kind of coming to an end of life, and you kind of decided something new was needed. Why, in brief summary, why did you feel you couldn't use what was already there, and you felt the need to go out and, I suppose, build something yourself and deliver? And why was that the RISC architecture? So breaking that down, why couldn't you have just taken something off the shelf like you had done, I suppose, with the first generation MOS 6502?
We did do all of that. We built prototypes. So we had a 4 megahertz 6502 second processor. We had Torch built a Motorola 68000 processor. Somebody else built a 6809. We built an 8186 processor, and we built a National Semiconductor, as it then was, 16032 second processor. And we started playing them off against each other and seeing how they performed. And that was quite disappointing, because you had the little 4 megahertz 6502 against an 8 megahertz 68000 or 8 megahertz 8186. And it was a draw, really. If you wrote the program right, then they were as fast as each other. And we formed a suspicion that the prime reason for the performance being identical was when you looked at all these systems, all the memory buses were all the same speed. So a 4 megahertz 6502 has a memory bandwidth of 4 megabytes per second, as does an 8 megahertz 68000, an 8 megahertz 8186, not that you could get one, and so on. So we formed a hypothesis that said the performance of these systems is directly proportional to the memory bandwidth. Now, if you remember, we were very good at building memory systems. So Steve had no particular problems saying, well, we could take the BBC Micro's memory system and make it wider, and then you'd have 16 megabytes a second. And we could make it go faster than that. I bet we could. And so he thought we could get one that was 32 megabytes per second peak. And there was nothing around that could use that type of memory system. So we began to think about building our own one. And that was a bit of a joke at first. But then several things happened that changed it from being a bit of a joke into being something that we became more and more convinced that we could do that.
Including, because it's famous, you visited, you went to Israel to see one company, and it was quite a large operation, and they were getting it wrong. And then you went to Western Digital, I think, in Phoenix, and you kind of, the light bulb went off because they were a small operation. What was it you saw in them that made you think the way they do? What were they doing that made you think they're doing it right, and we can copy the way their processes, we can do it the way they're doing it?
Well, yes, I mean, just to sort of complete a bit of Sophie's story, of course, we did market the National Semiconductor 16032, which later was rechristened 32016, as the basis of the Cambridge Scientific Workstation. And that was a dual processor with the NatSemi processor in it. So to address your question, we went to Phoenix, Arizona to visit Western Design Center, who were developing an address extended version of the 6502, which was the 65C816, if I remember my digits in the right order.
65SC816.
Was it? Yes. And you know, we went expecting to find, you know, the typical American company in the gleaming glass office block. And what we found was a bunch of people working in a bungalow in the Phoenix suburbs, using school kids in their vacation to design cell libraries. And it all looked much more like the kind of homebrew activity that we could relate to. And we did sort of come away from that saying, well, if they can design a microprocessor, just maybe we can, is the way I remember it. And we've been tinkering, you know, we'd had the sort of early risk papers slapped on our desks saying you might find this interesting. Was it Hermann who found those, or?
No, it's Andy Hopper who's
Andy Hopper
dumped. So he put the IBM 801, the Berkeley RISC-1 and the Stanford MIPS-1 papers on our desks, and we read them. And we also went out to Israel to see National Semiconductor. So that was your typical enormous tilt-up building full of engineers and white-coated people. And I think we saw them around about revision H of the 16032. And it wasn't really shippable until about revision K or something. It was dreadful.
Yeah, so the traditional microprocessor business was based in most instances on serious industrial teams taking several goes to get things right. But of course, the Berkeley RISC-1 account was of a postgrad class developing a competitive microprocessor in a year, based on the RISC principle, which is basically, to my mind, the principle of keeping things simple. And simplicity seemed like a highly desirable characteristic to use to guide as a design principle for a microprocessor, and it worked with RISC, and so that was the approach we took.
At a high level, how does one keep it simple? How are these other guys making it complex? If it's possible to sum that up.
Well, the Berkeley RISC-1 had enormous register file, and then some very strange ways that the register file was partly moved onto a stack automatically, which was very complicated. The Stanford MIPS had delayed branch. So with delayed branch, you'd execute the branch and you'd also execute the instruction immediately after it. And if you got an interrupt while you were doing that, then there was a small amount of chaos, and we never could work out how they dealt with that amount of chaos. So we thought, well, let's leave that out then. So we innovated on what we knew how we could do, and if we could work our way out to doing something like load multiple, store multiple, and make our machine do it, then we put it in. And if I wanted something like decrement and branch, if not zero, and Steve couldn't work out how that would fit into the microarchitecture that he was designing, then it wouldn't go in. And it was a tension between, we used to walk down from Acorns buildings to the pub at lunchtimes with Hermann, and we'd be talking about our latest tension between the instruction set design and the instructions microarchitecture that carried it out, and explaining where we were and how that was working out.
Okay.
I mean, Hermann often says that he gave us things that National Semiconductors couldn't give their engineers. He gave us no money and no resources. We had no alternative but to keep it simple.
It's the great British way, isn't it? Just conscious of the time here, so I've got a couple of good questions come up from the audience. Andrew's asked, what was on your wish list of upgrades to the BBC Micro after launch, and how did that compare with what was delivered in the B and the Master and so on? So any thoughts on that?
Well, I think immediately after launch, there were a whole string of add-on boxes that the BBC was expecting to arrive, from teletext decoders, which would do software download. You remember, this was before the days of the World Wide Web. It wasn't actually technically before the days of the internet, but the internet was not widely available at that time. And so teletext software download was a kind of the nearest we could do to building our own internet capability. Second processors, so I sort of moved on fairly rapidly to the 6502 second processor that Sophie's already mentioned, and other things. And then, of course, Chris Curry wanted a machine to compete more directly with Sinclair. And so we had to go and think about how to build a cost-reduced BBC Micro by making even more extensive use of ULAs, and that was what became the Electron.
We didn't really participate in a lot of the BBC Micro direct successors. So the B Plus and the Master, they were Paul Swindell and Martin Gilbert, respectively, running those teams. So Steve and I were off doing AR&D, Advanced Research and Development, leading to the ARM and all its chips. So,
because I mean, the BBC Micro, it's 40 years since it was launched, but I think it first shipped in January '82, didn't it? And by mid '83, we were tinkering with ARM design, so it's not that long after. The first ARM chip was 26th of April 1985 when it landed on our desks, and that was about 18 months after we started in earnest.
Okay. And here's a good question. You piqued someone's curiosity there, Sophie, when you said you were locked in a cupboard. The Drupal community has asked, what were the actual working conditions like at Acorn? Were you being sweated horribly then, or was it a nice collegiate atmosphere? What was it like working for Acorn, for Hermann at that time?
it was startup squared. So you have to work hard at startup companies, and throughout all this period, from about 1979 to about 1985, Acorn was essentially a startup for the engineers. So we were working 12-hour days, 7 days a week. So I vividly remember that there was a white Sony Triniton TV in the corner of the lab with the Royal Wedding playing while we were respectively programming or debugging hardware.
So you missed the Royal Wedding, or it was running in the background?
Yeah, I think Sophie's slightly overstating 12 hours a day, 7 days a week. I don't remember doing that myself, because
you had a family to go to. I didn't.
I had a family and daughters being born. In fact,
Yeah.
eldest daughter was born the month the BBC Micro was first shipped.
It's a test of your loyalty, if nothing else, isn't it?
Younger daughter was born in the middle of the ARM development period. So
Yeah. So I mean, we were in a large open space, the top of the building behind the electricity works in 4A Market Hill. And that space, Hermann or Chris had paid some local handyman to come and build us desks. And it used very rough hewn timbers to make the desks in the big space. There weren't any proper desks. So you ran a risk of getting splinters.
that was 81. I mean, Acorn moved out to Cherry Hinton in the end of 81, didn't it?
We got too big to stay in that building.
Yeah.
Okay.
And then we had proper desks. And then in 83, we got Herman Millard. Woo.
Well, at least they were concerned about your lower back. Let's put it that way. That's always a good thing. Another question. This is from Ollie Restorick. Excuse me if I've not pronounced that correctly. Now that Hermann's gone, what were your feelings on producing Electron as a cut down BBC Micro? Do you feel it was the right move? Obviously, you're the engineer guys. You'll do whatever the management tells you. So, you just. I
don't think we were very enthusiastic. I think. Although we went with the plan, I think our view was that we should be going sort of upwards rather than downwards. But as I say, Chris was very keen to compete more directly with his former boss at Sinclair. And that involved bringing the price down significantly.
So Electron took away all the good bits of the BBC Micro, as it were. And in particular, we got to have a slower memory system. And that was a source of angst, because we liked going fast.
Yeah, you guys were made for speed. This is a curious one. It sounds like a bit of an urban myth, but I'll put it to you anyway. Is it true that the case is made from the same material used for police riot shields? for school wear and tear? I know that they were built tough for school wear and tear, but did you any insight on that?
I don't know, actually. That's not a rumor I've picked up on. And of course, the success of the BBC Micro in schools was not really quite what was anticipated when the case was fully specified. I mean, we had thoughts of it being educational, but the BBC, was not directly targeting educational use at the time. It was more educating the general public. I mean, nobody had any idea the way personal computers were about to take off. So it would have been impressive forethought if somebody had actually worked out they needed riot shield grade plastic to survive in classrooms. We had the keyboard turned out to be remarkably bulletproof as well, but it was expensive.
Was it just the materials for use at the time? Did anyone actually put any thought to thinking of ruggedizing this thing, or was it just, toys were tough back then, never mind computers, weren't they? The shells were tough.
Well, the BBC Micro case was a bit floppy, actually. It's
if you left too heavy a monitor on top of it, it would sort of sag down and crush the heat sinks on the video processor.
So if you wanted the monitor on top, you generally had to build some kind of platform to put the monitor on rather than sticking it straight on the case.
And just burning through a few questions, another one here. The question of Micromen came up there. There was a suggestion, I think Hermann said that was the race to build the prototype was pretty accurate. Overall, how accurate was the film? And who were the original Fred, Jim, and Sheila? Any thoughts on that?
I'll leave Sophie to answer the Fred, Jim, and Sheila question. I mean, my view of Micromen was they had done their homework. They'd been around and talked to all of us and extracted anecdotes from us. So the basic plot was based on anecdotes they'd been told. The anecdotes they were given were not always consistent from one person to the next, naturally. But most of the things that happened in Micromen were based on things that actually happened, somewhat sort of jazzed up to make it a bit more dramatic. And as far as I am personally was concerned, then I have to say I've never had a beard. I haven't touched a cigarette since I was 12. I do admit to wearing tank tops. I didn't start wearing glasses until my late 40s. But the actor who played me was not quite representing me as accurately as maybe he could have done. But the only thing I was a bit upset about was portraying me as chain smoking in the lab. And I think even in the early 80s, smoking in shared workplaces was not accepted. I didn't smoke anyway, but I think at the beginning of Acorn, it was allowed to smoke in your personal office, but not in a public space. But the media likes to use people smoking inside as representing a past era. It kind of conveys the impression. So
there was no smoking in the Acorn buildings, which meant that when Olivetti took us over and the chain smoking Bruno Soggio arrived, I got the funner to say, "You're not allowed to smoke in here."
Yeah, I mean that's one of the reasons why I'm fairly sure that smoking was deprecated in UK offices in the early 80s, because when we did get taken over by Olivetti and went to meetings in Italy, it was quite horrific to be in a meeting room full of people smoking. I really didn't like it.
Final question, and I think this is the last thing. I think I'm going to add a little one to this one too. This is from Andrew again. Did ARM? So I'm just paraphrasing slightly. Did ARM live up to your hopes for the machine and the processor? And secondly, I'm going to load this one. It's a very loaded question. Did the BBC Micro live up to your hopes, do you think, when you look back over these last 40 years?
I mean, from my perspective, I think both of those things went way, way beyond our expectations at the time. I mean, it's already been mentioned. I think you mentioned actually, Gavin, that the BBC Micro it was targeting sales of 12,000 and ended up at 1.5 million. And you know, actually played a much bigger societal role than we expected or had any right to expect at the outset. And of course, the success of the ARM has just been formidable. I was talking to some old ARM hands last week, and apparently the number of ARM-powered chips shipped has now passed 200 billion. So, I mean, you don't sit there designing something, anticipating it will sell 200 billion in 40 years' time. That's just not what you do. No. You hope it'll make a nice desktop machine for Acorn.
What about you, Sophie? Expectations, etc., for ARM and the BBC Micro met, exceeded, within expectations?
I think we'd have to say greatly exceeded expectations for everything. I mean, we never really thought about much of this at the time because we were just doing stuff all the time. You didn't get time to look back. And it was probably only about 1990 when ARM as a company was formed that you got a chance to look back and think, well, that was pretty wild. Even then, looking forward, you couldn't have guessed how much wilder it was going to get.
That's a great note to leave it on, I think. 40 years ago, it all happened tomorrow, 40 years ago, and here we are sitting on the bit. Well, I'm going to thank you, both of you, and I'll thank you, Hermann, in absentia. He obviously had to go off and do some other stuff, but it's been brilliant speaking to you. Really enjoyed it, and I hope everyone else has as well.
It's been a pleasure. It's always entertaining talking about old times.
Entertaining to see what Hermann comes up with next.
Yes.
Waiting for that phone call.
An email nowadays.